There you go.
Morning everyone, myself Samir. We built a voice controlled AI assistant with ESP32 and ChatGPT. And this is like we use the ESP32 for record voice commands and use ChatGPT for the responses. Like how we can integrate a large language model into the IoT environment using ESP32 microcontroller to create a voice controlled AI assistant. Now our main objective is to develop an interface between ESP32 and cloud-based large language model services and optimum large language model services interaction for low power and with resources constrained like IoT devices, like create a functional voice control AI assistant prototype to demonstrate large language models capabilities into IoT. Now the methodology already takes away many.
Alright, so this is the methodology that we took for the project. At the beginning, we started by assembling the necessary hardware components. Then we integrated the speech-to-text API. We had to establish the connection with the large language model. Then we had to integrate the text-to-speech API to convert the responses back into audio. We would then implement the data compression for efficient data transfer. And then we just evaluate system performance for accuracy and responsiveness. So I'm going to talk a little bit about the findings. So for starters, audio is an analog signal, so we have to convert it to digital. Can I get the next slide? Previous one. There we go. We also had to choose carefully the hardware. Well, this is just a diagram of how the I2S interface works. We used to be working with different kinds of hardware that's not compatible with this communication protocol, so we had to make that decision. There's many types of formats that data comes in, so especially for audio, we have many formats, and that's very important when working with the API. We have to make sure that the data format is correct. We also have resource constraints. As we know, the Arduino platform, or the ESP32 is a very resource limited hardware component, so we were limited on the storage side of things and also on the processing, so we had to make some changes in regards to the hardware. Finally, the API integration was also quite complicated, so we had to go with a Node.js server. That means that not everything happens on the ESP32, but also on the cloud. And lastly, we also learned that the OpenAI API, called ChatGPT as we call it, can be fine-tuned for our liking, so we can tweak it to meet our needs. And this is what the diagram looks like. So at the start, we have the voice input here, which is a question that the user asks. It's taken by the microphone, processed by the ESP32. Again, because of the hardware changes that we made, the ADC is being done at the microphone, not necessarily at the software. The audio signal goes to the server, which then asks the API to transform it into text, and the text goes to the ChatGPT API, which then goes back to the ESP32 and sends it over serial communication to this other board, which then translates it back to speech, goes to the amplifier, and then we do the response here. And then I'll pass it on to Martin.
Hi, it's Martin here. As a future work in this project, integrating IoT sensors and actuators, we can explore incorporating a wide range of IoT sensors and actuators to expand personal assistance capabilities, improving the performance and reliability, optimizing the system for low latency and upgrade responses to improve user satisfaction, and leverage cloud-based services, utilizing cloud-based platforms to handle complex large language models processing, and try to demonstrate the IoT project that emerging the fundamentals of large language models and the ESP32 microcontroller. Even though we achieved the basic fundamental functionality of assistant, voice assistant, we faced with a series of problems. And when we are trying to solve these problems, we realized that what's the limits of doing this regarding to software or hardware or network issues. But in the end, we conclude that in this area we are expanding a lot of expansion of this area because we are in the end as a nature we human beings are social by itself, so we are more tend to feeling more comfortable with the things that we can communicate easily, and the AI assistant is a really good example of it. And as a final conclusion, leveraging cloud-based services is essential for integrating complex LLM capabilities into resource-constrained IoT devices. By offloading computational tasks to the cloud, we can enhance device performance and expand potential applications. Any thoughts or questions? Thank you for listening to us.
Any questions? You want to stop the recording or is it?
Do you have any visual setting?
Yeah, no, it's okay.
Do you have any visual setting like if the internet is not connected, it can have a store that you cannot do anything or something?
Yeah, the whole thing works on the fact that it has internet connection. So, as Merger explained in the conclusion, the whole idea of the project is that we can do all the computation on the cloud. So we're working with a very small microcontroller here, right? Like it's got very limited resources. So it is limited to an internet connection. Yeah. If we wanted to develop it so that it didn't need internet connection, then we would have to run the whole learning large language model on the microcontroller, which would be very difficult to accomplish, right?
Any more questions? So I really like the presentation. It was well designed and logically structured. So you introduced that new topic in a very clear and creative way. And I really like that you talked about the challenges you face and lessons learned. I do have a few questions. So you include Node.js as a middleman, right? So this will add latency to your product. So have you explored any other way to just decrease that latency or eliminate that and improve responsiveness of the system?
Can you go back to the diagram? That one right there. So, yeah, the Node.js server is the middleman of the whole operation. The reason why we went with that is because of how easy it was to implement the APIs in that language, because it's definitely harder to do it like on the microcontroller, right? Like using C, for example, instead of JavaScript. That is right. It added a lot of latency, and if we wanted to decrease the latency, then I would say we would have to decrease the number of components. Again, the diagram is, even though it's a simple version, it goes through a lot of steps, right? Like we have two boards, we have the server, and then like the APIs are working on two different sites. So maybe we could try to run the whole thing on a single board, and if it's possible, run the API calls from the microcontroller itself rather than the server. So I would just eliminate the server altogether.
So yeah, I understand that this is just a demo, it's just a prototype, and so you will consider eliminate or add any other alternatives in scaling up, right?
Yeah, I guess even if you like, my understanding is that you could bring it down to the board itself rather than.
So you want to design a hands-free voice control interface, right? That that's the ultimate goal.
I would say so, yes.
So, in your reports, you mentioned that the main target will be smart home section, but I can see that you can use it in different applications as well.
Yeah.
So, have you ever considered the security of your data? For example, because are we going to store the data? Or no?
Which data, the recording?
Yeah.
Well, the recording is stored on this board right here. It's just a 5-second recording, so it's stored locally. But then it's also sent to the server, and then of course it's then shared to all the APIs and stuff, so that means that the data can be shared.
Basically, that you mean that we won't have any sensitive data, right? To be transmitted and stored.
Can you say that again?
So we won't have any sensitive data to be transmitted and stored. So we won't deal with the like data security.
I think each time we are asking questions, the old report is deleted, so it's refreshing every time, right?
Yeah.
We are not
We won't store the data.
no, we are not storing all the time.